Hello everyone, let's solve a problem from GATE 2016, question number 35 from Aerospace Engineering paper. The question is, consider a second order linear ordinary differential equation d square y by dx square minus 4 dy by dx plus 4y is equal to 0 with the boundary condition y of 0 is equal to 1, dy by dx of x is equal to 0 is equal to 1. So the value of y at x is equal to 1 is dash. So we have been given a second order ordinary differential equation. We have to solve that. So we will get an equation with two constants. For finding those two constants, we have two boundary conditions, right? At x is equal to 0. Then after finding that, we will have a function of y. So in that function, we have to find the value of y at x is equal to 1, right? So let's go and solve the problem. So this is the question given to us, d square y by dx square, this is minus 4 dy by dx 4y is equal to 0. So in order to find the roots of the equation, so we have to equate the function of d is equal to 0, right? Wherever d is d by dx. Okay, so then we'll get d square minus 4d plus 4 equal to 0, right? So then we'll get d minus 2 and d minus 2. Okay, our lambda is 2 comma 2. Okay, then we will get the equation of the form a plus bx e power lambda x. In this case our lambda is 2, which are real and repeated roots. So then we'll get the equation of this form, e power 2x. So we have to find the constants a and b. For that we have the boundary condition. Our first boundary condition is y of 0 is equal to 1, right? So if we just substitute, 1 is equal to a plus b of 0, right, e power 0, which will give us a is equal to 1. Right? So then we substitute our second boundary condition, which is first derivative is 1, dy by dx of x is equal to 0 is 1. So for that, first we have to find the first derivative. Now this becomes y is equal to 1 plus bx e power 2x, right? So if we find the first derivative, then we will get 1 plus bx 2 into e power 2x plus e power 2x into b, right? So then we will get e power 2x is taken common, then we will get 1 plus b plus 2 into 1 plus b plus b. This is bx, right? So then our y dash is 1, e power 0, 2 into 1 plus 0 plus b. Okay, so then we have 2 plus b, right? So then our b becomes 1 minus 2, our b becomes minus 1, right? So now we substitute the value in a constant b in 1, so then we will get b is minus 1, 1 minus x into e power 2x. Okay, so this is what we get. Now we want to find the value of y at x is equal to 1, right? So then if we substitute 1 minus 1 e power 2, right? 1 minus 1 is 0. Y of x is equal to 1 is 0, right? So let's go back to the options. Our option A has the correct answer for this question, which is 0, right? So if you want to know more about similar concepts, you can refer to the course Engineering Mathematics 1 by Professor Jitendra Kumar from IIT Kharagpur. You can also refer to the lecture number 57, which is Solution of Higher Order Homogeneous Linear Equation. The link for that lecture is given here. Okay, so that's all for this question. Thank you.